Now, welcome to electrical machine lecture. In the previous lecture, it has been discussed the losses in the DC machine or DC generator, power stages in DC generator, and condition for the maximum efficiency. Now, today we will solve some numericals based on losses and efficiency. This is the example. A shunt generator delivers 195 ampere at terminal voltage 250 volt. The armature and field resistances are 0.02 ohm and 50 ohm respectively. The iron and frictional losses equals to 950 watt. Determine EMF generated, copper loss, output of the prime mover, and efficiency. So now we will solve this numerical. What are the parameters are given? The load current is given IL, which is equal to 195 watt, 195 ampere, and the terminal voltage VT, it is given as 250 volt, whereas the armature and field resistance RA is equal to 0.02 ohm, whereas the shunt field resistance RSH, it is equal to 50 ohm, and iron and frictional losses are given. So if you draw the circuit diagram, it becomes easy. So this is DC shunt generator. So shunt generator, field winding in parallel with the armature winding. And this is load. Whereas the load current is given as it is delivered, means it is finally delivered to the load. So load current IL is equal to 195 ampere at terminal voltage 250 volt. 250 volt. So from this figure, this 250 volt is going to appear across this terminal, armature terminal, and same across the shunt field terminal. So we can calculate ISH, shunt field current. So ISH is equal to VT upon RSH, which is equal to 250 upon 50 ohm. So it is equal to 5 ampere. This is the, therefore the load armature current IA, armature current IA is equal to IL plus ISH, which is equal to 195 plus 5 equals to 200 ampere. Now armature current we know the armature resistance, that is a RA we know. So simply we can calculate the first part, that is the EMF induced EG is equal to VT plus IARA. The brush drop is not mentioned in the numerical, so we considered as the brush drop is negligible or it is 0. So it is 250 plus armature current is 200 multiplied by the armature resistance, and EMF generated EG is equal to 254 volt. So this is the one parameter. This is one unknown quantity. It is determined. Now what is the next? Next is the copper losses. So where are the copper losses? The copper losses are going to take place in this field winding and this field winding. So we can calculate copper loss, total copper loss is equal to Cu loss in armature plus Cu loss in field winding. That those places where the copper losses are going to occur. The copper loss in armature, it is Ia square Ra plus similarly the shunt field current Ish square Rsh. So if you put the values, armature current is 200 square into 0.02 plus 5 square into 50. This RSH can be calculated as simply the terminal voltage Vt into Ish. Both way we can calculate. Therefore, the total copper losses equals to 2050 watt. This is the total copper losses. Now, what is the next? Next is we want to calculate the output of the prime mover. Output of the prime mover means suppose it is connected with the prime mover. So output of prime mover is nothing but the input of generator. So to calculate the input of generator, it is necessary to know the output plus losses, whatever the total losses over there. So now it is given that as iron and frictional loss, iron and frictional loss, which is maybe called as a iron plus frictional or mechanical losses are called as a stray loss, equals to 950 watt. It is given. It is given in the numerical itself. Okay. Therefore, the total loss is equal to stray loss plus total Cu loss, which is equal to 950 plus the total copper losses is 2050 watt, and it is equal to total losses in the machine is or generator is 3000 watt. So here the total losses now ready. So what is the input of the generator? Input of generator is equal to output plus losses. So what is the output? Output is it is delivering 196 ampere and 250 volts. So V into I or Vt into IL plus 3000 watt, which is equal to 250 multiplied by 196 plus 3000 watt. So the total generator input is equal to 71. So generator input is equal to, sorry, it is equal to 551,750 watt. 750 watt. Now this is the input of generator, is nothing but the output of prime mover. The same thing. Now efficiency. Efficiency of generator is output divided by input, which is equal to, what is the output? Output is V into IT. So it is a 250 into 196 divided by the output of primer or input of the generator is 51750 into 100. So the efficiency is of the generator is 98.2. 98.2%. So this is the efficiency of generator. Okay. So this is the first numerical. Second numerical is a shunt generator has full load current of 196 ampere at 220 volt. The stray losses are 720 watt and shunt field coil resistance is 55 ohms. If it has full load efficiency of 88%, find the armature resistance and also calculate or also find the load cross corresponding to the maximum efficiency. So here the generator is delivering 196 ampere shunt generator as earlier. So so here what is given? The full load efficiency is given. So first we will calculate the output of generator, which is equal to Vt into IL. Here Vt is terminal voltage is 220 volt multiplied by 196 ampere. Therefore, the output of generator is 43,120 watt. This is the similarly. Now, efficiency is equal to output divided by input, whereas the efficiency is given 88%, means it is a 0.88. If you multiply by 100, then we can write as 88%. So it is 0.88. Output we know 43120. This is the output of generator divided by input. Therefore, input equals to, this is input is equal to 43,120 divided by 0.88. So it comes 49,000 watt. So this is the input of generator. Now, what is the total losses? Suppose the motor, this is the generator, this is the power stages, it is the mechanical input. Then there is some windage and frictional losses, gross electrical power developed, copper losses, and this is the output of generator. Okay, so just we draw the power stages. So using power stages, it is become easy to understand. So this is output, this is input, it is output. Output is nothing but Vt into IL, whereas input, it is now 4 49000 watt, and output we have calculated 43,120 watt. So this is the input, this is the output, and in between this losses are there, say windage and frictional loss, and CU loss. So you can calculate total losses. Total losses is equal to input minus output of the generator, which is equal to 49000 minus 43,120. So it comes around, total losses is 5,880 watt. This much is the total losses in the machine. Now, as the armature resistance is given, terminal voltage is given, we can calculate the other parameters like shunt field current ISH. It is equal to, the terminal voltage is 220, shunt field resistance is 55, so it is equal to 4 ampere. Shunt field resistance, shunt field current we know. Therefore, armature current IA is equal to IL plus ISH, which is equal to, load current is 196 plus 4 equals to 200 ampere. So this is the armature current. Now, as we know the armature current, it is possible to calculate the copper losses in the shunt field winding. So CU loss in shunt field is equal to simply 220 multiplied by 4, or you can write as I square into RSH. It will give the same result. So 880 watt. Now see, in this one, here copper losses in the armature and shunt field winding. So if you subtract the total losses, minus copper loss minus stray loss, say just we'll write the total one, then it has become simple. So as it is given that the stray losses is given, yes, the stray losses is equal to 720 watt, which is given. It is given in the numerical. Therefore, constant losses, therefore constant loss is equal to shunt field CU loss plus stray loss equals to what is the shunt field copper loss? It is 880 plus 720. So the total losses become 16,000 watt. So this is the constant loss. So we can write as a constant loss, WC is the constant loss. Okay, it is a constant loss. Therefore, armature CU loss is equal to total loss minus WC, constant losses, which is equal to, what is the total losses? The total losses is 5,000 880 minus 1600, which is equal to armature CU loss is equal to 4280 watt. As it is already discussed, the generator gives maximum efficiency when variable loss equals to constant loss. The things we have already discussed. Therefore, we can write as I square R loss, IA square RA is equal to the constant loss. RA square RA is equal to the constant losses. It will give the maximum efficiency, isn't it? So armature copper loss 4280, and hence it is equal to armature resistance RA equals to 0.107 ohm. This is the one parameter we have found. The second parameter, it is asked to determine the current corresponds to maximum efficiency. So IA maximum, the current is not a maximum, under maximum efficiency, which is equal to under root WC is the constant loss divided by armature resistance RA. So the current under maximum efficiency is equal to 122.34 ampere. So this is the second parameters as per the numericals. Okay. Now the next numerical, quickly we see a long shunt generator running at 1000 RPM supplies 222 kilowatt at the terminal voltage of 220. Long shunt. So long shunt generator, this is the winding, series field winding, armature, and this is the load. This is the load. So what are the points are given? The voltage is 220 volt. Load is 22 kilowatt. It is running at 1000 RPM. N is equal to 1000 RPM. Terminal voltage is 220 volt. Load is PL, load is equal to 22 kilowatt. The resistance of armature shunt field winding, so armature is 0.05 ohm, whereas shunt field winding is 110 ohm, and series field winding is 0.06 ohm, isn't it? So first what we will do, we will calculate the current. So load current IL is equal to load divided by terminal voltage. P is equal to V into I is a power. So it is equal to 22 into 10 raised to 3, convert into the watt, divided by 220 volt. So the load current equals to, load current is equal to 100 ampere. Now we can calculate this is the load current now. IL become 100 ampere. Okay. Now ISH, shunt field current. ISH is equal to terminal voltage 220 divided by 110. So it is 2 ampere. Hence, IA armature current is equal to 102, or say it is 100 plus 2, it is 102 ampere. This is the armature current. We are going to find out the copper losses, and the efficiency, overall efficiency is given. So what we'll do, we can calculate the losses. We can calculate the losses in the generator, and from the losses, we are going to define the say output of the generator, input of the generator. So first we will calculate the CU losses. CU loss in shunt field. So shunt field is 2 ampere multiplied by the resistance 110. So it is equals to 440 watt. This is one parameter. Now CU loss in armature is equal to 102 into 0.05. So the armature copper loss is equal to 520.2 watt. Similarly, CU loss in series field winding, which is equal to 102, because the current delivered by the current flowing through the series field winding also the same as that of armature. Only the change is multiplication of the resistance 0.06, and the total field resistance is shunt field, the series field resistance losses are 624.3 watt. Hence, total CU losses. Total CU loss is equal to the losses which is going to take place in first, second, and third in 3 winding. 440 plus 520.32, plus 624.3 watt, and it is comes to total copper losses equals to 1584.5. Now we get the total copper losses. As we know the output, as we know output is equal to 22,000 watt, and efficiency for this load it is given 88%. Therefore, input is equal to input power is equal to 22,000 watt divided by efficiency 0.88. It is therefore the input is equal to 25,000 watt. So this is the output, this is the input. The difference of these two values is nothing but the total losses. So total losses is equal to 25000 minus 22,000 watt, and it is equal to 3000 watt is the total loss. Now, once we calculate the total copper losses, this is the total losses. The difference of these two is nothing but the iron frictional losses. Therefore, iron and windage and frictional loss is equal to total loss minus total Cu loss, and therefore the losses is equal to 3000 minus 1584.5, and this is equal to 1415.5 watt. So these are the iron, windage and frictional loss. Iron, windage and frictional loss. So in this way, we can calculate the efficiency, losses, and copper losses, variable losses, current corresponding to maximum efficiency, and so on. So thank you for this lecture.